What kind of problem is this?
A word problem.
Yeah, it's a word problem. Good. All right. But we know that it's a molarity problem, hopefully, right? You guys recognize the word concentration is, or should be used interchangeably with your little either brackets or the big N. All right, so we're solving for big M here. All right, so for sure, we need to have what two pieces of information? Moles and liters, right? Okay, so do I give you either of those? No, of course not. All right, so you have 12 grams right here. You want to make sure you get that converted over to moles, right? And then this 400 milliliters right here needs to get converted into liters. So to help each other out, how do we at least convert the 400? What do we do with that decimal? 3 to the left. Good. So we're going to go 1, 2, 3. Okay? So don't forget to do that. You're going to get your concentration. Before you dive into this, though, pay attention for one more second. All right. So if you notice, I'm giving you what? What is this? Who is that? You can say it. You can say it.
Oh, sodium hydroxide.
It is sodium hydroxide, right? What does hydroxides tell us? Is that acid or base?
Base.
Base, exactly. So the kicker here is I'm asking for pOH first. Why do I have to ask you for pOH first? Can you throw a base right into the pH scale and be perfectly fine and be like, hey, I counted up all the hydrogens because there's a lot of hydroxides? No, right? So the whole idea is this whole pH and pOH is counting up how much you have. If you have a base and you do that negative log of its concentration, you are in the pOH scale. Then you have to move to pH, okay? So just know when you do the negative log, you're solving for pOH first. And then how do we get to pH? 14 minus, right? 14 minus pOH, okay? All right, so I'm going to give you guys a couple minutes. Go ahead and get that worked out. And we'll be back up. There you go. All right. So you should have started out with your 12 grams of NaOH, right? And then we said 1 mole of that was equal to about 40 grams. When you did that, you should have gotten 0. Help me out, 3 moles, okay? So now that we have that, we can throw it over our liters, which was 0.400 to get your molarity, right? And then from there, you had, your molarity was what? 0.75. Thank you. Okay. 0.75 was your molarity, so that's your concentration of OH minus. Okay? So what we can do with that information, let me shrink it, I wrote that really big. All right. What we can do with that information is we throw it into the negative log. Sorry. pOH was equal to the negative log of that 0.75, and you got something like 0.125, correct? Yeah. 0.125, all right? And so that's your indication that you are not done yet, right? Because we know on a pH scale, bases should have higher than 7. So this should be your indication that you're like, oh, that's right, one more step. And so what you're going to do with that is you end up doing your 14 minus, and you got 13 point what? Just 8.7? Just any of those. That's fine. All right. So you got a higher pH, and that should make sense because it's basic. All right? We're all good with that? Okay, so what you need to get yourself to, though, okay, just so you know, and I kind of got around to telling some people this, was I should be able to give you this question right here and take out this whole POH. I should be able to say, given all this information, what's the pH of it? Okay? And so you got to think in terms of, do I have an acid or a base? Is that pH or POH? And then what do I have to do? Okay? So we'll get there. But good job. Nice work. All right, so in your packet, turn to page, all right, so on page 5. What?
Pressure. Not this.
No pressure. Kind of a bit pressure.
All right, cool. So in this little equation, basically what we're going to be talking about and what you're going to have to walk away with is what this K thing is. All right, now you guys haven't done equilibrium yet. Equilibrium is going to have a bunch of these Ks. You're going to have like KC, KSP, K everything, all right? So what these Ks that you guys are worried about, and we'll learn about KW tomorrow, okay? But the K that you guys are learning about today is going to be KA and KB. So just go ahead and write up at the top, KA, KB. Better? Okay. All right, KA, KB. All right, so what these values are, what these little constants are, these guys are called ionization constants. All right, so just write ionization, am I still on the screen? Yes, constants. Okay. Who can tell me from yesterday what the word ionization was used for? No.
Adding an extra.
All right, it was, yes. Yes, this. Exactly. So when you ionize, it means you're dissociating or you're dissolving or you're turning yourself into ions, basically. So which one out of the two, weak acid or strong acid, has a more chance of ionizing? Strong acids, right? Strong acids, that's what makes them strong, is the whole idea that they ionize. They split up. Okay? So we need to be able, and it's true for bases as well. Strong bases are going to be the same thing. So what we're going to be doing is we're going to look at values given to us about these Kas and Kbs, and we're going to decide, is it a strong or weak acid? All right? Now, in order to look at that, we got to focus in on this little equation that we've got here. What is something that kind of sticks out to you on this little equation? What's kind of different besides the ha and the ah? That's when everybody's all day.
K equals H3O.
No, not that. I'm talking about the balanced equation. Huh?
Oh, with the 2 arrows?
The 2 arrows, yeah. Isn't this kind of weird to y'all?
A little bit.
There's an arrow going forward, there's an arrow going backwards. And that arrow means just that. It's going to go both ways, all right? And so what you can kind of think of is think of a seesaw. If I'm going to put more stuff on this side, it's going to kind of shift to the right. If I put more stuff on this side, it's going to shift to the left, all right? So your equilibrium idea is the fact that it can go both ways, all right? So let's go ahead and just label that arrow so that you know what it is when we get back to it later on in life. That when you see a double-headed arrow, it means it's at equilibrium. That's an M. Woo! That's really the best M you've ever seen. Thank you. All right. Okay, so it has to do with equilibrium, all right? So one of our first questions that's on this page is asking whether this is a strong or a weak acid. What did we just say was true about strong acids? Do they kind of stay together or do they all split up? They all split up, right? Do you guys remember when we had the 2 pictures? If you flip the page over, the packet over, flip your packet over real quick. Just the packet, whole packet. You see that picture? Yeah, remember that when we talked about how it was forming a bunch of the hydroniums versus staying together, right? So hydrofluoric was your weak, and your hydrochloric, which split up and made a bunch of hydroniums, was your strong. So go back to this little equation. And above it, what I want to do is I want you guys to write out what a strong one would look like. Would a strong one have this little back and forth arrow? What do you guys think it would have? An arrow, just one arrow, right? So when you have a strong acid, it's going to look more like, it's going to look more like Ha plus some water yields all H3O and a bunch of floating around ions that don't affect anything. Okay? This one's H2O. The other one's H3O. Okay? So that's a strong. So go ahead and label this one as a strong. So what do you think this other one that we have in front of us actually is?
Weak.
It is totally a weak. So we're going to label Ha, because this H tells us that that's an acid. We're going to label this guy as a weak acid. Okay? Weak acid. All right? What is H2O? Water. All right, so we're just gonna kind of X him out because it's not too important. It's just kind of our medium that we're working with. Okay. What is the hydronium talking about? What's important about hydroniums? What is that like a big indicator of? It's an acid, right? It's a big acid. So we're gonna. Okay. Just put acidic. Meaning, if we have more of that, that means we're very acidic. If we have more of the weak acid, we're not as acidic. All right, that's what you guys are going to kind of think of. All right, and then what do you guys think that little A minus thing is? You take away the H, what do you have left over? Think about our example that we had. We had something like HF, right? What would be left over if I took away the H? Just fluorine, okay? So, what this guy is you guys can go ahead and call him a salt or an ion. All right? Y'all done? Okay? So these are our different parts of this little equation, okay? And when we're talking about, like I said, the Ka and Kb values, we really care about it more for our weak acids because what we want to know is how much is this thing going to actually ionize or dissociate, okay? We already know strongs are going to completely dissociate. So we want to know between the weaks, which one are the stronger weaks versus the weaker weaks, right? Does that kind of make sense a little bit? So we're kind of, we're scaling the weak ones. I'll get back to you, Ethan. Good. All right.
Now everybody knows it was.
All right. So let's look at this little equation now, okay? This is what gives us the those values. It tells us which way is that reaction going, forward or backwards, okay? Who is on top in this equation?
The acidic.
In terms of reactants and products, who is on top, you guys?
Products.
Products, right? These are your products. So go ahead and write this. Go P over R. All right? It is products over your reactants. And we don't include water because, like I said, water is just the medium. It's just holding it. It's giving us that option to turn into an acid. All right? So don't worry about water. He's always not included. Poor water. All right? But it's going to come down to products over reactants. So we got to use a little bit of logic here. Okay? You guys ready for that? Use some math skills here. You guys can cross out this. We already answered that. And cross out number 14. We're just going to use their little spaces. Okay? Okay, so we're going to use the little space right here on 13. All right. So if Ka is products over reactants, okay, Kb is also products over reactants. By the way, what do you guys think the A is? Acid. What do you guys think the B is? It's exact base. Bases. Okay, it's just that easy. So if you're dealing with an acid, you do A. If you're dealing with a base, you do B. All right? But looking at this little problem, if I have more products, okay, so in the end of all this, if I have more products, what do you think that means about my Ka value? If I have more products, so more numbers on the top, what happens to the Ka? Is it big or is it small? Okay, so we're struggling with that one. All right, so take a look at this. If you need to write it to help you out, you can, okay? If I start off with 1 over 1, and all of a sudden I now have 2 over 1, did I just get bigger or smaller? Bigger, all right. So if I have more products, I have a big K. Okay? You all good with that? Okay, on the other hand, if I have more reactants, what happens to my K? It gets smaller. Oops, sorry. I guess I should keep it consistent. There you go. Small K. All right. So that's all fun and games. So we can say, yay, so I have a small K, so that means I have more reactants or more products or whatever we want to say. But what does that mean in terms of strong or weak? Well, look back at our equation one more time. If we are making more acid, so if we're heading towards the, sorry, there you go. I was looking for the pointer. All right, so if we are moving towards this guy right here, if we're moving towards our hydronium, are we a strong acid or a weak acid? If we have a lot of hydronium, are we strong or weak? Very strong, right? That's what makes you an acid. If we have a lot more of this weak acid, what are you going to say we are? Weak, right? Okay, good. All right, so if we are moving towards our products, big K, am I a stronger or weak acid? Strong, exactly. And that's the part that you guys got to write down, all right? So big K means you are strong, okay? Little k, on the other hand, means we are moving towards our reactant. So what does that mean? We are weak. Okay? All right. So that's the big idea that you guys need to know. So real quick, I want you to look down at 15 and 16, and I want you to try and answer those. Okay? Try and answer 15 and 16. In terms of just this. Will it be greater than or less than 1? Will it be greater than or less than 1? For a weak acid versus a strong acid. Okay? Answer it on your own. All right, so for number 15, we said a weak acid will be most likely greater than or less than 1. What did you guys say? Less than. Good. All right, and the reason why is because Ka or Kb, whatever you have, okay, is products over reactants. Who do we have more of for a weak acid? We have more reactants, exactly. We're shifting to the left. That's the whole idea of an equilibrium thing, is you're shifting one way or the other. We're shifting towards the left in a weak acid. It favors staying weak, all right? When you have a strong acid, what'd you guys say? Greater than, right? All right, so greater than. And our reasoning is because who do we have more of? Products, right. We're doing more dissociating, more ionizing. So we have a big ionization constant. And that's the whole idea, okay? So you guys are going to give this a try. You're going to, I believe, just flip your packet over. Go back to that little table that you guys have. Okay, I'm going to leave this here for a second so you can finish copying. And if you look below, you have this little chart. What you're going to do is you're going to be circling the one of the stronger acid or base. Now, before you get started, if you notice, all of these guys have exponents, right? You guys see that? Okay, so we're gonna write ourselves a little hint down here at the bottom. Okay, so we know that strong is the same thing as more dissociation, which is more products, which means what for K? Big or small K? Big K. Let's put big K. But because these all have exponents, we have to know what those exponents mean. So up here on the board, I kind of wrote an example, so if you don't want to write it down, you can just look up there. Otherwise, give yourself this little example, which is that if you have something 1 times 10 to the negative 1, that is the same thing as me saying 0.1. if I have something that is 1 times 10 to the negative 8, so a bigger exponent, bigger negative exponent, that is the same thing as me saying 0.000000001. Which one of those two is bigger? The first one, right? So you want the smaller negative exponent for a bigger k. So when you go to look at your answers, you're looking for the smaller exponents. Easy?
So easy.
Super easy. Not too bad. All right. So I'm just going to put that little hand up here, and you guys go ahead and do that, and we'll check back in a minute, okay? All right, so here's your answers, okay? Once again, you're just choosing the one with the the smaller exponent, okay? So you can check your answer. As soon as you're done with that, you guys are gonna go to page 7. Okay, so go ahead and turn to page 7. Yeah, that's your favorite.
No.
So glad this is getting recorded, you guys. Thank you. Appreciate it. All right. So page 7 looks like this. It's obviously a POGL. A couple things that I want you to do to yours, though, real quick, before you dive into this. Okay. For the cation, in my opinion, we should not be writing H3Os because the cation in that acid was just the H. So if you want to write the H3Os, that's fine. However, a lot of us have changed this to just be H+ for all of those answers. All right? Because technically, that's what your cation is. It's just the hydrogen part. Okay? The other change I want you to make is look across to the other side. I want you to not put so much focus on trying to fill out this. The most important part on this POGL is probably these last 2 columns. That's the connection you're going to have to make. You're going to look at what its polyatomic is, and you're going to see how that affects its naming. All right? So work with a partner, and whatever you don't get done is going to be for homework, but make sure you come get a stamp from me to get your credit for this. And then about 2 minutes to the bell, I will give you guys the answer to number 10. Okay? Cool.